Okay, good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. We are going to continue on with our lesson by looking at those factors that affect temperatures. And so far, if we double check on what we have covered on the board, we have completed work on latitude. And generally, when we're looking at latitude, the further away we go from the equator, the cooler it gets. Altitude is to do with height. For every 1,000 meters of rise, we go up. Temperatures decrease by 6.5 degrees Celsius. Hotter by day and cooler by night. Generally, because the sun shines during the daytime, the temperatures of the areas where they are directly in line with the sun are hotter than those that are experiencing night. Hotter in summer, colder in winter. Again, because the sun is closest to that hemisphere at the time of the year, it is summer, therefore temperatures would be much more hotter compared to the hemisphere which is furthest away from the sun, where it experiences winter and it is colder. Our last lesson, we looked at distance from the sea, and I also mentioned that with the work on distance from the sea, this is mainly marked in the temperate regions. And for our lesson today, we are going to go ahead to looking at cloud cover. And if we do have time, then we will move on to looking at ocean currents. So those factors that are yet to be covered will be cloud cover, ocean currents, aspect, and also pollutants in the atmosphere or in the air. We will look at cloud cover today. And as I've mentioned, if we do have time, we will look at ocean currents as well. But before we go on to looking at cloud cover, let's recap on what we have covered on distance from the sea. Generally, one can say it is hotter and cooler away from the sea. What does that mean? Because land surfaces, they heat up and cool down much more faster than water surfaces, the further one moves inland away from the sea, the less effect the sea has on temperatures. In other words, we are trying to see the relationship between temperatures and the distance away from the sea. Therefore, the further one goes inland from the sea, the hotter the summers the hotter the summers tend to be, and the colder the winters. Okay, this particular statement was illustrated and explained with a diagram. If we looked at the diagram here showing us information on mid-summer temperature conditions in a temperate latitude, we also already note that the land heats up quicker compared to the sea. And because the land heats up quicker, it absorbs heat quickly. Therefore, places further away from the sea will tend to be hotter compared to those that are closer to the sea. Why? Because the sea heats up slower, the cool air blowing in towards the land will cool the coastal regions that are closer to the sea, resulting then in the temperatures which are closer to the sea to be a little bit more cooler compared to those places further inland. This is mid-summer temperature. Then we come to mid-winter temperature conditions in the same latitude. This time, the sea loses its heat slower compared to the land. And because the land loses its heat more rapidly, it is winter, then what happens is that the places further inland would be colder compared to those that are closer to the sea, because the sea then, losing its heat slowly, will bring in warm winds, warming up the coastal regions. Therefore, temperatures along the coast here will be warmer in comparison to temperatures of areas further inland. We looked at perhaps an example, and I only mentioned about 53 degrees north latitude, a place closer to the sea, which is affected by the sea. Therefore, it is said to have maritime influence, and those areas which are affected as a result of them being further inland, they tend to have continental influence. So maritime or oceanic influences are those areas that are affected by the sea, which are closer to the sea, and those areas that are affected by the fact that they are further inland are said to have continental influences. So here we have two areas, one located here, Valencia, and the other one, Banal. We can note the explanation as given in terms of the land heats up quicker and cools down quicker. The sea heats up slower and cools down slower. And when we look at the distance from the sea for those two locations, then we are able to work out in summer which area would be warmer, and in winter which area would be warmer, and vice versa. In summer, which area would be cooler? In winter, which area will be cooler? And also in summer, which area would be warmer? Okay, and that is what we have covered on distance from the sea. Anyone with any queries or questions with regard to that information that we have looked at on distance from the sea? Were you able to take your notes or get your notes down on that information from our booklet? Everyone able to get your information from the booklet? Okay, we'll move on then today with the work on cloud cover. We mentioned that cloud cover is also one of those factors which affects temperature. From what we have covered already in insolation, we know that cloud cover or clouds generally radiate or reflect most or some of the radiation from the sun back into outer space. And because clouds are able to do that, we can also note that clouds can contribute to the temperature or difference in temperature of a particular place. We have two different examples to look at to understand cloud cover and the relationship it has with temperature. The first area is looking at an equatorial region. Okay, in an equatorial region by day, so it is daytime, perhaps Papua New Guinea. Incoming solar radiation, not all of it comes right through to the surface. When they come through, if there are clouds, then the clouds tend to radiate or reflect some of the radiation back into space. So the 100% or say, for example, 50 units or so that are coming through may not come right through to the surface. Along the way, if there are clouds, some of it will get to be reflected back by the clouds. Meanwhile, we are looking at the outgoing radiation. Where is this outgoing radiation coming from? It is already from the 50% of solar radiation or insolation, which is actually used to heating up the ground and the air around it. That radiation then is or will not be able to escape, because if there are clouds, then the heat which is radiating back through will bounce off from those clouds and come back to the surface. As a result of that, the area here will get hotter. So the clouds then, they act as a blanket to prevent the loss of heat. And not only that, they act as an umbrella not to allow so much incoming solar radiation through to the surface. This is by day in an equatorial region. Let's look at by night. If it is nighttime, again, clouds then will prevent the excessive loss of Earth radiation. So in night now, or if it is night, the clouds itself here will not allow so much of the radiation to actually escape. And as a result of that, if you have a nighttime with cloud cover, you will tend to find that the place is a little bit more hotter in comparison, perhaps with nighttime where there are no clouds at all in the sky. So the cloud itself here acts like a blanket which prevents the outgoing radiation to all escape. Therefore, it will contribute to hotter temperatures below. Let's look at the second example. This time with the second example, an area whereby there is hardly any clouds. And we're looking at the desert, a hot desert region. This time by day, look at the incoming solar radiation. It's coming right through. Why? There is absence of clouds, which then results in the maximum of solar radiation reaching the Earth's surface. Therefore, by day, it is very hot. Let's move on to by night, still in the hot desert region. By night, there's hardly any clouds here, clear sky, therefore it allows the Earth's heat to escape freely. So most of those radiation that has come in during the day now escapes. Without any cloud cover, they will not be blocked to come back to heat up the surface. Therefore, in a hot desert region during the night, the temperatures can be cool to cold. And the reason for why this happens is simply because there is no cloud cover to prevent the radiation or heat that is escaping. So when we look at cloud cover, generally, cloud cover can contribute also to variation in temperature. Where there is a lot of clouds, it prevents the heat from escaping. Therefore, the temperatures tend to be warmer or hotter. And where there is no cloud cover, then most of the heat gets to be radiated or escapes back to space. Therefore, the place is a little bit more cooler. An activity now that I'd like you to do so that we can maybe look at the relationship between cloud cover and temperature. And the activity is to explain in a paragraph how clouds can influence day temperatures and also night temperatures. We had 2 case studies to look at. We looked at the tropical regions, and we also looked at the desert regions. And perhaps your explanation should include those 2 areas, tropical regions and also desert regions. I'll give you about 5 to 7 minutes to come up with an explanation, and then we'll get a couple of students to read out what you would have written. For those students who are fast and who might have completed their written explanation, you can go ahead to copying down the diagram, and the diagram you will find on or in your booklet on page 7, and that is figure 10 on page 7, that you can make note of the diagrams. I'll have to decide whether I should give you a stamp or not. Title of the talk. Give that. Yes, what was your question? You can refer to the equatorial regions, or you can look at the desert, as long as, to help you be able to understand, because in one case there's a lot of clouds during the day, during the night. In the other case, there's hardly any clouds during the day, in the night. So if you are able to explain using those 2 examples, it might make it easier for you to write your paragraph. Page missing, and so that's page 7. Can you look on? You look on to somebody else who has got the information. This one is for the 2. Homework diary, the hottest time of the day. Okay. Maybe I can give you a stamp for what you've got done so far. Okay. Did you understand the work on the... Okay. So, we'll want to give you a stamp if your information is in pen, corrections are done, etc. Did you do the work for yesterday? No. Okay, so that means you have to catch up with what we have done so far. Did you understand the information we looked at, distance from the sea?
It depends. It depends on how far the air which is being carried. Remember, when air is actually carried across, what will happen to it? It will not only blow across, it rises, it cools, and then condensation takes place. So it depends on how far the process of cooling and condensation and all that takes place. So it can be a great distance depending on the rate, or it can be a very close. Sometimes it's very close that precipitation occurs very quickly because of so much moisture is carried and the heat and the coolness lifting it up quickly to result in precipitation. Sometimes it takes a longer distance, so it really doesn't matter how far, but the distance will depend greatly on how fast the air is able to cool, precipitate, or condense and precipitate. What happened to what goes here? Okay, I'm not going to give you a stamp if you are not going to have the diagrams completed. You see, okay. You've got to prove to me that you are able to get that stamp here. So I will not give you your stamp now. Whose book is this? Is this yours? That's yours. Okay, so you've gone as far as completing that work. Well done, it's all right. Did we understand everything that we've covered on distance from the sea? I think you deserve to get the stamp. Yep, you got your homework already. I'll give you one. What's today? Tuesday, right? What is that book for? Just general note taking beside what you've got in. Okay, that's fine. As long as most of your information is in here, that's fine. Whatever we cover, which is a little bit maybe more information, then you make notes. So your extra notes you attach together with this. Okay. Am I able to give anyone anything? Have you completed my work from yesterday? No? This one is not even completed? Yeah. Oh, okay. Let's check. This is from the sea. What's this? And this one here? You deserve to get a stamp if you're not completing work. Pressure, sunshine here. What goes here? It's so there. You'll have to make sure your work is up to date. Do I deserve to give you a stamp? You don't think so? Your exercise book, I'd like to check. Exercise book. Now this is looking really good. Okay. We are here. Where's the second diagram? To be completed. Maybe if it was completed, then I'll give you a stamp. But because it's not completed, I will not give you the stamp there. There. To be completed. I want you to be updated with your information. Yep. All this to be in pen. Okay. I think you deserve to get the stamp. Today is the
Okay, we better check on this information and then we will move on then with ocean currents. Anyone from the class would like to read out your paragraph explaining how clouds can influence day temperatures and also night temperatures? Celeste, would you like to read out what you have got written down?
Clouds have a great influence on day and night temperatures. For example, in the equatorial regions by day, The clouds absorb and reflect solar radiation, whereas in the desert regions, the temperatures are extremely high due to the absence of clouds. And in night, the equatorial regions experience warmer nights compared to the hot desert regions. This is because there are no clouds in the desert regions, and thus all the heat on the Earth's surface is reflected back into the space.
Excellent. Actually, very good. Well done. I think if your explanation is similar to what Celeste has actually written down, then you have definitely understood the relationship between cloud cover and temperature. And he used the two examples, equatorial region by day and night, and the tropical deserts by day and night. Very good explanation and well done. And the rest of us should make our corrections based around what Celeste has actually read out. You double check. Your information similar to what has been read out? Yes? Well done. Okay, we move on. With the next information I'd like us to look at, the next information now is going to be the next factor that affects temperature, and that is on ocean currents. For our work on ocean currents, we will require atlases, so that with the atlases we are able to plot in the different major ocean currents around the world. How does ocean currents influence temperature? When we look at the surface waters of the oceans, they have a pattern, and the pattern movement is also in a slow, ill-defined stream, which are called currents or drifts. In other words, our oceans, the waters in the oceans especially, they tend to actually move in a slow and ill-defined streams, which are referred to as currents or drifts. So when we are looking at the names of the different ocean currents, most of the ocean currents will have at the end of the name drifts. The Mid-Atlantic Drift, the Benguela Drift, and etc. So when we talk about drift, we are referring also to currents. But these surface movements, they are mainly caused by winds, evaporation, and differences in temperature and salinity. We are not going to look at much on evaporation and salinity, also differences in temperature, but we will concentrate mainly on the fact that the surface waters are greatly caused by winds. Major planetary winds also contribute to the movement of surface water, resulting in drifts or currents being created. Our task now is to see how ocean currents can contribute to making temperatures differ from one place to another. And the places that are greatly affected will be those areas that are adjacent to the currents, the ocean currents. If we go further inland, perhaps it might not be greatly, or the areas will not be greatly affected. So therefore, we are concentrating mainly on the adjacent land to where the ocean currents are flowing. One of the basic rules that we need to remember when we are looking at ocean currents is, if we have the equator, the North Pole, and the South Pole, we'll tend to find that warm currents are those that flow from the equator towards the poles. Warm currents are those that flow from the equator towards the poles, simply because around the equator, the temperatures are warmer or hotter. Therefore, the body of water that is moving away from the equator towards the poles tend to be warmer or hotter. Cold currents are those that flow from the poles towards the equator. The reason being that they are coming from a colder region, and the body of water will be cooler or colder. So something may be very simple for us to understand about ocean currents. Warm currents are those that flow from the equator towards the poles. Cold currents will be those that would usually flow from the poles towards the equator. The reasons: hotter at the equator, body of water will be warmer or hotter. Colder at the poles, the body of water that is flowing will be colder or cooler. We also note that for the movement of the surface water to take place, winds are the principal factor, and also the major ocean current circulation corresponds to the major wind movements. In other words, the surface movements are greatly caused and affected by winds. We looked at evaporation, salinity, and temperatures as other factors that also can contribute to the movement of the water or the currents or the drifts, but wind is the principal factor that has the biggest influence on the movement of the surface water, which are known as ocean currents or drifts. We'll move on. This time, we are looking at some of the main ocean currents that we have around the world. Your atlases, you can now make reference to your atlases. There are different atlases that will contain the information on ocean currents. And because we are using the Papua New Guinea Secondary Atlas, then you can make reference. Okay, if you look at page 134 of your atlas, there are two maps that are given, and those two well maps generally give us an idea, and also it gives us the names of the different ocean currents. We have to also recognize some of those different ocean currents and know where they are flowing or within which region they are flowing, and whether they are warm currents or cold currents. Before we go ahead to looking at the map and completing some activities, let's look at the information from the monitor here quickly, showing us some of the main ocean currents. The information from the monitor here, you can see the red writing plus the red arrows representing the warm ocean currents, and the blue writing plus the blue arrows representing the cold currents. Some of the warm currents are, some of them are the South Equatorial Drift, the North Equatorial Drift. The Gulf Stream is an example of a warm current. The North Atlantic Drift is an example of a warm current. Kuroshio in Japan, an example of a warm current. The East Australian Drift, which is a warm current. The Mozambique Drift, the Brazil Drift are all examples or some examples of the warm currents. Let's look at the cold currents. The cold currents, the Labrador current is a cold current. The East Greenland current. Kamchatka current is a cold current. Californian current. The West Wind Drift is a cold current. The West Australian Drift, a cold current, and the Benguela current, cold current. With our information, perhaps from the atlases, we should be able to make a list now of some of those warm currents and cold currents. But when you make a list, put them under the heading, warm currents together, cold currents together. Before you go ahead to making the list, let's remember this basic and simple rule about ocean currents. Any current which is flowing from the equator towards the poles are termed warm currents. Those that flow from the poles towards the equator are termed cold currents. Okay, let's look at the activity now, and our activity will require us to use our atlas, and let's make a list then of the different ocean currents under the headings warm currents and cold currents. I'll give you 5 minutes.
You have to check your. I'm looking at first of all whether you've completed the work on it. Where's your paragraph? Yet to be written. Oh, it's for today and it must go in. Okay, let's look at what you've done yesterday. I think you deserve to get a stamp, so I'll give you one. Welcome. How many stamps have you got so far? Getting there to 5. Distance from the sea, where is altitude and put them together. I want to see them all your note taken together. Latitude. You deserve to get a stamp. How many stamps have you got so far? Have you reached 5? Exercise book. What's this one for? Drawing. Make sure it goes in. I want your work to be up to date so that I can give you a stamp. Exercise book. Your exercise book. Shelley, you have your exercise book. Okay. Then when everything is in order, I should be able to give you a stamp. Otherwise, I will not be able to give you a stamp. You definitely deserve a stamp. You sent it. Got your homework done ready? Yes. Yes, yeah, definitely. Remember I said ocean currents or drifts? Bring it sometimes today so I can, if you want me to give you a stamp. Your book. We're still way behind now with our note taking, so we'll have to update it so that I can give you a stamp.
Okay, let's check on those answers, and then you can complete whatever is not completed by double checking on the atlases for your homework. What I am going to give you may not be the only ones that you should be listing. You go off for your homework and you find if there are some occurrences that are missing from our list here, you must also include, but be sure to note whether they are warm currents or cold currents. The blue writing obviously tells us these are the cold currents. So let's check again. You check Labrador, the East Greenland, Canaries, Benguela, West Wind Drift, West Australian, Kamchatka, and California as some examples of cold currents. See if you can add to the list by checking for your homework other cold currents that are not mentioned here. Okay, the warm currents, the North Atlantic Drift, that's 1. Gulf Stream, 2. North Equatorial, 3. South Equatorial, 4. Brazil, 5. Mozambique, 6. East Australian, 7. And Kurosuo, 8. But again, these are not the only cold currents. See if you can find, these are not the only warm currents. See if you can find some more warm currents and include to your list. You might be wondering, so how does ocean currents have an influence on temperature? Here goes. Those areas that are closer and the cold currents actually flow adjacent to where the land masses are, the areas tend to be warmer as a result of the warm currents, bringing in warmth to the land, heating up the land more compared to perhaps places further inland. Those areas that are closer to where the cold currents are flowing, in summer especially, if a cold current is flowing through, then what will happen is that the coolness from the water will contribute to the adjacent land becoming a little bit more colder. And that is how the currents influence the adjacent land. If it is a warm current and if it is winter, the warm current will contribute to warming up of the adjacent land a little bit more compared to if it is winter and we have a cold current. The cold current will make that area more cooler in comparison. And it's vice versa in winter. For your homework, make a list of the other currents that are not included here, and also see if you can write a statement that will show us the relationship between ocean currents and temperatures. Okay, class, that will also bring us to the end of our lesson. If you can stand up now, please. To the pilot teachers, our keyword for lesson 107 is ocean currents. Good afternoon and thank you, students.